Hi guys, and welcome to another video. In today's video lesson, we are going to be looking at grade 11 and 12 maths, Euclidean geometry, proving that the angle at the center is twice the angle at the circumference. And this is how it appears in an exam question. In the diagram, O is the center of the circle. A, B, and D are points on the circle. Use Euclidean geometry methods to prove the theorem which states that angle AOB is equal to 2 times angle ADE. When we do any proof, the first thing that we must do is we must understand what the construction is in this particular proof. In understanding the construction, we must understand why do we do the construction, what reasons are going to be used in this particular proof. So let's look at that very carefully. The construction in this proof will be to produce DO to a point E. You can call it any point. The second thing that we are going to do is we're going to call this angle here D1. We're going to call that angle D2. We're also going to call this angle O1 and call this angle here O2. The other thing that we're going to do is we're going to let D1 equals to X. We're going to let D2 equals to Y. So the construction is produce DO to E. After that, we're going to let D1 equals to X and D2 equals to Y. Now, the second thing that we must be able to do is understand what reasons do we require in this particular proof. The reasons required in this particular proof will be OD equals to OA equals to OB radii. The reason for that is that when we have radii, and if you can now look at the triangle OAD, we'll have equal angles opposite equal sides, which means that this angle A will now equal to X and this angle B will equal to Y. The other reason that we need to use in this particular proof is the exterior angle of a triangle. If you look at the triangle O, area angle of the triangle, and remember that the exterior angle of the triangle is equal to the sum of the interior opposite angles, which will now make O1 2x. Similarly, O2 is the exterior angle of triangle OBD. Therefore, O2 is going to equal to 2y. And there you go, that's our proof. If you look at it carefully, ADB is equal to x plus y, and AOB is equal to 2x plus 2y, which makes AOB 2 times ADB. So let's write all of that down. Number 1, what did we do? Our construction was produce DO to E. In our proof, the first thing that we did was we let D1 equals to X. And we let D2 equals to Y. Then the first reason that we used was that OD equals to OA equals to OB radii. So therefore we wrote our first statement with its reason. We said OD equals to OA equals to OB radii. OD equals to OA equals to OB radii. Therefore, D1 equals to A equals to X equal angles opposite equal sides. Similarly, D2 equals to B equals to Y equal angles opposite equal sides. And then the next reason that we used was the exterior angle of a triangle equals to the sum of the interior opposite angles. So O1 equal to 2x. Exterior angle of triangle. And O2, there's O2 here, is equal to 2y. Therefore, what can we conclude? We can conclude that O1 plus O2 is equal to 2x plus 2y, which is equal to 2 into x plus y. What else can we conclude? We can conclude here that ADB is equal to x plus y. So at the same time, what is O1 plus O2? O1 plus O2 is AOB. There's that whole angle. So therefore, AOB is equal to 2 into x plus y. ADB is equal to x plus y. Therefore, we can write our concluding statement that AOB is twice ADB. And there you go. The angle at the center is twice the angle at the circumference. So once again, the things to notice in this particular proof, or to remember, is number one, our construction, reduce DO to E. Second thing, in our proof, let D1 equals to X and D2 equals to Y, which is the angle here at the top. Also remember that OA equals to OB equals to OD right here. Remember that these letters A, D, and B may change in the examination. So it's important for you just to remember your reasons. We're also going to be using equal angles opposite equal sides, and the exterior angle of a triangle equals to the sum of the interior opposite angles. And therefore we are able now to do our proof. That is, if you haven't subscribed already, subscribe to JL Maths. Also, watch all videos in order of the work schedule on jlmaths.com. You can also like my Facebook page, Justin Lazarus Mathematics. And I'll catch you in the next video.